Hi everyone, in today's lesson we're going to talk about graphs of hyperbolas. A hyperbola sort of looks like two mirrored parabolas with the two halves being called branches. So this and this is technically the graph of a hyperbola. Same thing here, this or this is the graph of the hyperbola with these two things looking kind of like parabolas. Now, like an ellipse, a hyperbola has two foci and two vertices. So these two things are called the vertices, where the branches begin. And then we have the foci, which this time are actually a little bit further from the center than the vertices are. This is unlike an ellipse. And there are no co-vertices here. Okay? Now we have some unique characteristics of hyperbolas. Instead of a major and a minor axis, we have a transverse axis. So our transverse axis here is our main axis. It includes the center, the two vertices, and the focus. So the center, the two vertices, and the foci. So that's what we're going to write in here. It includes the center, the vertices, and the foci. Okay, now just like in an ellipse, the vertices are A units from the center, which are located on the transverse axis. Okay, so our vertices are still A units from the center. So if you want to label it, the distance from here to here is A, and the distance from here to here is A. Now the foci are inside each of these branches, and they're still C units from the center. So again, if you would like to label it, from the center to the foci are C, center to the foci are still C. Now something else that's unique is that hyperbolas have asymptotes. So these dotted lines going across here and here are our asymptotes of these two branches. They eventually go somewhere, they're approaching a line, and that's the asymptote. Now the conjugate axis, which is this part here and here, helps us determine the B values. Now, on ellipses, our B values were our co-vertices. We don't have co-vertices, but we need a B value. So these two distances are our B's. So if you want to label it, from here to here is B, and from here to here is B. Okay? Now, once we have our A values and our B values, we can make this box. Okay, now this box helps us because see how this asymptote line goes through these 2 points? We need the box to make both of the asymptote lines. Okay, so let's read this part again. It says the conjugate axis helps us determine the B values, which helps create the box to make the equations of the asymptote lines. Okay, now since the C value is greater than the A, or the foci is further away than the vertices, it changes the formula that we use to find A, B, and C. So this formula is C squared equals A squared plus B squared. So instead of C squared equals A squared minus B squared, it's C squared equals A squared plus B squared. Okay? So let's look at the equations of what hyperbolas look like. So that's very, very similar to an ellipse. So it's x squared over a squared minus, this time, y squared over b squared equals 1. And if the center is not at the origin, again, it's x minus h squared over a squared. Oops, this should not be a plus. Please fix that. This should be a minus, and this should be a minus. So the two formulas are x squared over a squared minus y squared over b squared equals 1, and then this one when the center is not at the origin. So how do I know if the hyperbola looks like this or if it looks like this? So with ellipses, we said if the bottom number, the first number, was bigger than the second number, and vice versa. The horizontal hyperbola, which is this one, will happen when the x squared comes first in the equation. If the y squared comes first in the equation, then we have what we call a vertical hyperbola. Okay? The a and the b don't change in this one. The a and the b stay the same. Okay? Now, the asymptote equations are here and here. I'm going to talk about those a little bit later on, so don't stress about those too much just yet. Okay? Let's see if we can graph these things now. Okay, the first thing we want to analyze is if we have a horizontal hyperbola or a vertical hyperbola. Now, since the x squared comes first, we have what we call a horizontal hyperbola. And because it says x squared, y squared, our center is at 0, 0. Okay. Now remember, a and b never change. So the a comes first, then the b comes second. So it's the square root of 25, which gives us 5. The square root of 1, which gives us 1. Okay, so let's start and graph what we have so far. Our center is at 0, 0. Our vertices, our a value is 5 and our b value is 1. So what we're going to do now is we're going to make that box, okay? So the vertices are on the transverse axis. So here's my transverse axis because we know it's opening horizontally. So we're going to go over 5 and left 5, okay? And those are my vertices. Okay, so we can put this V1 and V2. And then we're going to go, our B value is 1. Our B value is on the conjugate axis, so we're going to start at the center and go up 1, and then down 1. So this is my very small box that we're going to need, okay? So we can answer right now that my vertices are 5 and negative 5. So let's label those as 5, 0 and negative 5, 0. Now if I want to find my foci, I need to use the formula c squared equals a squared plus b squared. So we know that a squared is 25 and b squared is 1. So we get 26. C squared, and if we take the square root, we get the square root of 26. But we should probably make that a decimal, so why don't you pause the video, grab your calculator, and see what the decimal equivalent is at, and then hit resume when you're finished. Okay, I got that it was approximately 5.09, or 0.99. So we're just going to estimate a little bit here. So about here and about here, those are my two foci, so we could label those F1 and F2, okay? So now we know that our equation is going to look something like this and like this, but we need to know our equations of our asymptotes. Okay, before we can get into the equations of asymptotes, we need to review the equation of a line. So y equals mx plus b is the equation of a line. I'm just going to erase that. M is my slope. And b is the y value of the y-intercept. Okay, so when we make our equations of our asymptote lines, what we're going to have to do is be very careful because they're going to go through the center and go through the corners of the boxes, so here and here. So this would be one line, and then here's a corner, and another one, and here's another line. But be very careful because our asymptote lines need to be dotted, okay, because they're not actually part of the equation. All right, so make sure you somehow make these a little bit more dotted. Okay, now since we know that our hyperbola is going to look something like this, and like this, we need to continue this on so we have our barriers to go by. So watch. Our slope for this line is up 1 over 5. So let's continue it. Up 1 over 5. Now I know it's going to go off the graph a little, so we'll just estimate somewhere around here. Okay? And then same thing on this side, it's probably going to go off the graph. And then we could do the same thing with this one. We'll go down and over, and we'll estimate. So this time we'll go down 1 over 5. And then we'll estimate somewhere here. And then up 1 over 5, we'll estimate somewhere here. And those are the equations of my two asymptotes, okay? Again, making sure that they finish off dotted, okay? So, if I want to write the equations of these asymptotes, it's not that bad because the y-intercept for both of them is 0. So my b value here will be 0. So I just need my slope. So for this equation, we're going up 1 over 5. So that equation is going to be y equals 1/5 x. Now this next equation here, we're going to go down 1 left 5 is negative 1/5. So that's the other equation of the asymptote. Again, the center is 0, 0, so it doesn't matter what the y-intercept is. It's 0. Now, this is the easy part. Our equation of our hyperbola will fall in between these barriers, here and here. So we just draw a sketch of it, okay? So starting at the vertex, go this way, and this way, and that way. That is my hyperbola. Okay, I know that was a lot. So let's try another example. But actually, before we do that, I want to write down the foci equations. So the points are here and here. So we went radical 26, comma 0, and negative radical 26, comma 0. All right? Those are my foci. All right, let's see if we could try another example. Okay, the first thing we want to analyze is if this hyperbola is going to be horizontal or vertical. Now, since the y squared comes first, we know that it's going to be a vertical hyperbola. So let's go ahead and circle that. The center is still going to be 0, 0 because it's just x squared and y squared. So we can go ahead and label that. Now, the a is always what comes first, so the square root of 25 is 5. The b is always what comes second, so the square root of 36 is 6. Now we know the vertices are a units away from the center, but since it's opening up vertically this time, let's see where the vertices will lie. So let's graph what we know. Here's my center, and now since we know it's opening vertically, my vertices are actually going to go up 5 and down 5. So this is V2, V1. Now my b value is on my conjugate axis, which is 6 from the center, so here and here. Now that will help us make the box so that we can draw our asymptote lines. So let's just make a box around the vertices and the b values. Okay? So my vertices are at 0, 5, and 0, negative 5. So I'm just going to go ahead and label that in here. So 0, 5, and 0, negative 5. Now let's look at our foci. So it's c squared equals a squared plus b squared. And our a value is squared is 25. Our b value squared is 36. So 25 plus 36 is 61. And then take the square root. And let's see what decimal equivalent that would be. It's approximately 7.8. So I'm going to go ahead and graph those foci. So here is 7.8 is somewhere here. So this is my F1. 7.8 is somewhere down here. So that'll be my second thing. My foci would be F2. All right, now our equations of our asymptotes go through the corners of these boxes. So here's going to be one equation here and here. Okay, and then here and here. Now, obviously, we're not going to be able to continue this because I ran out of graphs, so we'll just kind of estimate here, and here, and there, and there. Okay, so if we want to write our equations, let's focus on this one first. So again, the center is 0, 0, so my y-intercept will be 0. But let's just see how I get from this point to this point. I went up 5 over 6. So my slope is 5 over 6. So y is equal to 5 over 6x. And then going the other way for this equation, we start at the center, we went down 5 over 6. So that equation is going to be y equals negative 5 over 6x. And then if we want to just draw in our hyperbola, we start at the vertex and we go out around towards my asymptote line. So here and here. Those are my two branches of my hyperbola. All right, let's see if we could do an example where the center is not at the origin. Let's move on to the next page. Okay, first things first, we're going to analyze the center. Okay, so my center is negative 5, negative 2. Okay, now it's not written, but since the x comes first in the equation, right, since x is coming first, we know that this is going to be a horizontal hyperbola. So let's write that down. Okay, now again, the a is always the square root of the first number, which is 1. And b is the square root of the second number, which is 7. So we know this is a horizontal hyperbola. So what that means is that we are going to go 1 unit to the right and left of the center. So let's go ahead and label our center. So negative 5, negative 2 is here. So our a value is 1 from the center, so here and here. So we'll call this vertice 1 and vertice 2. So if I want to name those points, it's 4, negative 2 and 6, negative 2. So we can label that 4, negative 2 and 6, negative 2. All right? And while we're here, let's find our foci. So c squared equals a squared plus b squared. A squared is 1. B squared is 49. So c squared is 50. Take the square root of 50. We should probably simplify it. 25 and 2. So 5 rad 2. And if we use our decimal equivalent to graph it, it'll be about 7.1. So from the center, we're going to go over 7.1 and left 7.1. So if we just count, 1, we'll start on this side. 1, 2, 3, 4, 5, 6, 7. 0.1 will be about here. 7.2, it'll be off the graph, so we'll say it's about here. So if we want to name those coordinates of the foci, the y value is still the same. The y value is always negative 2. So from the center, which is negative 5, we added 5 radical 2, comma, the negative 2 never changes. Then we took negative 5 and we subtracted 5 radical 2, and the y value of negative 2 never changes. Okay, so the last thing that we didn't do yet is our b values. So let's go ahead and label our b values, which are 7 units from the center. So we're going to go up 7 from the center and down 7 from the center. So here we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Somewhere here. So we can draw our box. Okay. So here are our vertices. And our equation of our asymptotes are going to go through this point here. And here. Here and here. It's going to look something like this and like this. We can extend them because it's probably difficult to graph the rest of it. And we can graph our hyperbola. So here, and here, here, and here. All right. Now, I know that's an extreme hyperbola. It's pretty large, but that's going to be our equation. All right, so the equation of the asymptotes is a little bit harder here. They're going to go through the center and each of these points. Now, if you think you can make the equation, by all means, give it a shot. Otherwise, we're going to do those equations in class tomorrow. All right, so what I'd like you to do for homework is to see if you could try, those equations of the asymptotes. All right, if you can't, don't worry, we'll go over it in class. All right, the last example that I want to do is number 4. All right, so since the y comes first rather than the x, we know we're going to have a vertical hyperbola. Okay, and the center is x comma y, so we have to look at the x first. So -4, +4. A is always the square root of the first number, so the 25 will give us 5. Square root of b is 3. Okay, so what I'd like to see if you could do, if I set you up with that, can you draw the picture of this hyperbola? All right, so for homework, I want you to try this, fill in the rest of this, and we'll go over the rest in class tomorrow. All right, have a good night.